Hi guys, this is Miss Gold. Today's lesson is Module 2, Lesson 12, Writing, Evaluating, and Finding Equivalent Expressions with Rational Numbers. Your outcomes for today's lesson are students create equivalent forms of expressions in order to see structure, reveal characteristics, and make connections to context. Students compare equivalent forms of expressions and recognize that there are multiple ways to represent the context of a word problem. And finally, students write and evaluate expressions to represent real-world scenarios. Let's start by taking a look at example 1. John's father asked him to compare several different cell phone plans and identify which plan will be the least expensive for the family. Use the information contained in the table below to answer the following questions. So we have a table of the different cell phone plans, and it shows you the different columns and what they represent. So we have a monthly fee, which includes 1,500 shared minutes. We have price per phone line, which is represented with the variable X. The price per line for unlimited texting is represented with the variable Y, and the price per line for access to the internet is represented by the variable Z. So all members of the family may not want identical plans, and therefore we will let X represent the number of phone lines, Y represent the number of phone lines with unlimited texting, and Z represent the number of phone lines with internet access. So I want to make an expression that represents each of the companies. So let's go through and show what the cost of each company is with an unknown number of phone lines, texting lines, and internet lines. So for company A, no matter what, you have to pay a monthly fee of $70. On top of that, you will pay $20 for each of your phone lines. So notice with the cost per phone line, if I had one phone line, I would pay $20. If I had two phone lines, I would pay $40. If I had three phone lines, I would pay $60. So really what we're doing with 20 and X is multiplying the two to tell us the total price. So I can represent the price per phone line as 20X for company A. And we're going to take that same logic to represent the price per line for unlimited texting. If I had one line, it'd be $15. If I had two, it would be $30. So again, we're multiplying by the number of lines. So this would be 15Y. And the last one, same idea, we would have 15Z to represent each line of internet access for the total cost of that. So once we've created company A, company B and C are going to follow in the same way. So we just need to change the numbers. So the monthly fee for company B is $90. Their price per line is $15, so this would be 15 times the number of lines. The price for unlimited texting is $10, so this would be 10 times the number of lines. And the price for internet access is $20 per line, so we would represent this with 20 times Z. For the last company, they have a monthly fee of $200, but you can see they have a lot less charges because the texting and the internet access is included in the monthly fee. So the price per phone line would be 10X. So these expressions represent the three different companies' prices without knowing the exact number of phone lines for each one of our variables. The purpose of knowing these expressions helps us to figure out different scenarios so we can calculate which one is actually going to be the best for this family. So let's take a look at part A. 4 people want a phone line, 4 people want unlimited texting, and the family needs 2 internet lines. So notice this tells me the numbers for each of my variables. So from 4 people want a phone lines was our X value. So in this case, X is going to equal 4. 4 people want unlimited texting, which was our Y value. So Y is also going to equal 4. And the family needs 2 internet lines, which was represented with our variable Z, is going to equal 2. So essentially what I'm doing is I'm plugging in these numbers into the 3 expressions. So let's go through and evaluate. Company A is 70 plus 20X plus 15Y plus 15Z. So I'm going to substitute the 3 different numbers that I now know for X, Y, and Z. So we will have 70 plus 20 times 4 plus 15 times 4 plus 15 times 2. So we're going to follow the order of operations here, and multiplication comes before addition in order of operations. So we're still going to have the 70, but we will actually multiply. 20 times 4 is going to give us 80. 15 times 4 is going to give us 60, and 15 times 2 is going to give us 30. Once I've done that, I can go through and add. And when I'm adding, I like to use some of our properties to help group things to make them easier. So for example, I know that 70 plus 30 will give me 100. So what we can do is use the commutative property to switch some of these around. So let's flip-flop the 80 and the 70, and the 30 and the 60. And then I'm going to use the associative property to group these two together. So we will get 70 plus 30 is 100. So we have 80 plus 100 plus 60. And then I can use the commutative property to flip the 100 and the 60 to get us 80 plus 60 plus 100. And I know that 80 plus 60 will give us 140. So the total for company A is going to be $240. Okay, let's take a look at company B. Same idea. I'm going to plug in the numbers that I know. So we have 90 plus 15. We're replacing x with 4. Plus 10. We're replacing y with 4. Plus 20, and we're replacing z with 2. Same idea as the last, we're going to do our multiplication first. So 90 plus 60 plus 40 plus 40. I can add my 90 and 60 to get 150, and 40 plus 40 is 80. And so when I add these together, this company is going to cost $230. So this is a little bit less than company A for this scenario. But let's not rule out company C, so let's evaluate this one. We have 200 plus, the only element that is plugged into this one is the X value goes in $10 per line, so this would be 10 times 4. So 200 plus 10 times 4 is 40. And we get a total of $240. So company C for this scenario costs the same as company A. So which cell phone company should John's family choose? Well, obviously they're going to want the best deal, and so in this case, it would be company B. Because it's the cheapest. And it's cheaper by $10. In part B, 4 people want a phone line, so that tells us X equals 4. 4 people want unlimited texting, so this tells us that Y equals 4. And 4 people want internet, so this tells us that Z equals 4. So what I'd like you to do is to pause the video, and I want you to go through and do the same process that we did for A, try to replicate it, and when you're done, press continue and you can view the solutions and see how you did with plugging in and evaluating. So take a second to look this over, make sure that you have a similar process, that you plugged in the correct numbers into each of the variables, that you evaluated correctly. Notice with company B, I chose here to use the commutative property to switch my numbers around. So I put 90 and 80 next to each other because I wanted 60 and 40 together because they make 100. Okay, let's do the same thing for C. I want you to go through and identify what each of the numbers for the variables are and then plug them into company A, B, and C's expressions, evaluate and answer the question, which cell phone company should John's family use and why? When you're ready to continue, unpause the video and check over your answers. So take a look at this solution. Notice that I have used the commutative and associative property throughout to help me add my numbers together easier. we found that company A in this scenario cost $170, company B $180, and company C $220. So notice they want you to see that in the last scenario, they were all equal to the same number and company C ended up being the cheapest. But in this case, when we have a lower number for each of those, company A is going to beat all three of them. Okay, let's take a look at example 2. 3 friends went to the movies. Each purchased a medium-sized popcorn for P dollars and a small soft drink for S dollars. Write the expression that represents the total amount of money in dollars the 3 friends spent at the concession stand. Now, there's actually 2 different ways that we can write this. It really depends on how you think about the scenario. One person might think that, well, I would have to add P and S together because they all bought a popcorn and a soda, so we could represent that in parentheses showing P plus S. And once I had that solution, I would multiply it by 3. Now notice the reason I put them in parentheses is that each one of those friends bought a popcorn and a soda, so we'd have to find that total first and add them together. So this implies the result of addition then is multiplied. Another way to think of it is separately. Each person bought a popcorn, so we would have 3 popcorns, plus each person bought 3 sodas, so we would have 3 sodas. So notice these expressions are representing the same scenario. So you can have multiple ways to represent this. Another way might be to break it up even further, and you could show each person is popcorn and soda, popcorn and soda, and popcorn and soda for each of the 3 friends. Part B says if the concession stand charges $6.50 for a medium-sized popcorn and $4 for a small soft drink, how much did the 3 friends spend on their refreshments altogether? So when I look at these 3 different scenarios, the one that I think is the easiest is this one right here. So what I'm going to do is plug in the values we were told represents the popcorn and the soda cost. So we would say 3 times popcorn costs $6.50. Soda costs $4. So order of operations says parentheses has to go first, so we're going to add these 2 together. So I get 3 times $6.50 plus $4 is $10.50. And then we're going to multiply that by 3 to get the 3 friends, and we get $31.50. Now that was just the way that I felt was the easiest. But if it's easier for you to use this expression and multiply each of them by 3 first and then add them together, that's totally fine. Or if you struggle with multiplication, notice you could have used this expression, plugged them in, and added all the numbers together. Whatever works best for you is fine. In this lesson, we have learned that an expression is a number or letter which can be raised to a whole number exponent. An expression can be a product whose factors are any one of the entities described above. An expression can also be the sum and or difference of the products described above. To evaluate an expression, replace each variable with its corresponding numerical value. Using order of operations, the expression can be written as a single numerical value. Finally, expressions are equivalent if they evaluate to the same number for every substitution of numbers into all of the letters in each expression.